Hello everyone, today we're going to continue our unit on graphing quadratic functions. And just to kind of lead us into what we're doing today, let's kind of review something we did before. So we've been dealing with quadratic functions that are written in vertex form, which you see here, okay? So what we've already done is we've graphed functions that are in vertex form. Today we're actually going to be graphing things that are in standard form, but just to kind of refresh our minds, let's go ahead and review graphing this function in vertex form. So the first thing we're going to do is we're going to find the vertex. So the vertex, we are going to find it right here. Okay, so the vertex of this thing is actually 1, 5. Okay, after that, we're going to make a table. So I've got a table here, and I'm going to put that 1, 5 in the middle of this thing. I'm going to pick two numbers on each side. So -1 and 0, 2, and 3. So when I sub -1 into this thing, -1 minus 1 is -2. -2 squared is 4. And -2 times 4 is -8. Plus 5, that's going to be -3. Okay. When I sub 0 in, that's going to be -1 squared is 1 times -2 is -2 plus 5, that's going to be +3. And then remember that this thing's going to be symmetrical, so this is going to be 3 and -3 on that side. So that gives me these points. -1, -3 is there, 0, 3 is up here, 1, 5 will be there, 2, 3 will go here, and 3, -3 is going to be there. And that gives us this graph. So that's how we graphed functions that were in vertex form. So moving on, today we're going to be looking at functions that are in standard form. So remember, standard form actually looks like this. Y is equal to ax squared plus bx plus c. Okay, and then so graphing from standard form uses the same steps as from vertex form, but the difference is the vertex is not immediately there in front of us. We're actually going to have to do some work to find it. Okay, so that's what's going to be different about this. So when we're dealing with equations in standard form, we're going to make sure that it is actually written in standard form. So we want x squared to be first, x to be second, and then our constant to be last. And we're going to find what a, b, and c are, just like we did when we did the quadratic formula. And just remember, if a is positive, that means we're going to be going up. Both sides are going to be opening up. If it's negative, it's going to be pointing down because it has been reflected. So the first thing we're going to do is find the x value of the vertex. And we use this formula right here to find that x value. Okay, so we're going to take whatever b is, make it negative, and then divide it by 2 times a. And that's where our vertex is going to be. This is also our axis of symmetry. And then to get the y value, we're just going to substitute the x value in, and that will tell us the y value. So let's take a look at an example of this. So this function here, all right, so first thing, it is in standard form. Let's identify what a, b, and c are. So a is actually -1, b is 2, c is -3, okay? So now to find the vertex, we're going to say x is -b over 2a, okay? So b is 2, so that's going to be -2 over 2 times -1, which that is -2 over -2. So we get x is equal to 1. That's our x value of the vertex. And then we're going to take that and sub it in to find the y value. So that's going to give us f of 1 is equal to -1 squared plus 2 times 1 minus 3, and that is going to be -2. So we end up with y is equal to -2. Okay, so the vertex of this thing is as the point 1, -2. Axis of symmetry is just x is equal to 1. So now on our table, we're going to put that in the middle, 1, -2, and we're going to pick x values on each side of that. So 0 and -1, and then 2 and 3. These are my x values. Okay, so when I sub -1 in, that is going to give me -6. When we sub 0 in, it's going to give us -3. And remember, these things are symmetric, so this is going to be -3, and that's -6. So that gives us these points, -1, -6, 0, -3, 2, or 1, -2, 2, -3, and 3, -6. So here is the graph of this function. And that's it. So it's really not that much different than vertex form. Okay, so this should actually say standard form here. Okay, it's not much different than vertex form. We just have to find where the vertex is first. So let's take a look at another example. Okay, so first thing, find where that vertex is. We need to figure out what A, B, and C are. So A is 2, B is -16, C is 28. Okay, so we get X is equal to, let's just write the formula, -B over 2A. So the opposite of B is actually going to be +16 over 2 times 2, and that's going to be 16 over 4. So X is actually equal to 4. All right, now find the Y value. So we're going to take that 4 and sub it in, and we get 2 times 4 squared minus 16 times 4 plus 28. Okay, so that is going to give me 32 minus 64, so that's -32, -4. So Y is -4. So there's our vertex. Our vertex is 4, -4. Axis of symmetry is just x is equal to 4. So put that in the middle of your table, and then we're going to pick two x values that are smaller. So 2 and 3, and 2 that are bigger. So 5 and 6. And now let's substitute those in. So 2 squared is 4. 4 times 2 is 8. All right. -16 times 2 is -32. So 8 minus 32, that is -24. Plus 28, that's going to be +4. Okay, then we sub 3 in. All right, so 3 squared is 9. 2 times 9 is 18. -6 times 3 is going to be -48. So that's -30. -30 plus 28 is -2. And then remember, this thing is symmetrical, so we're going to see the same numbers on the other side. So we get these points here, 2, 4, 3, -2, 5, or 4, -4, 5, -2, and 6, 4. And that gives us this graph. And that is our quadratic function here. Okay, so what you should be able to do today is graph the equation of a quadratic in standard form. So we should be able to create this graph if we're given an equation that is in standard form. Okay, so please go check out the assignment that is on Canvas, and let me know if you have any questions. Have a great day.